one's Petra. So, I know you want to do that. You're not going to climb up there though. Okay. Now your little tiny paws are on there. I magically swapped out the cat for a cup of coffee. We're going to find the arc length of the parabola y equals x squared between the points 0, 0 and p 0, 0, the origin, and q 1/2, 1/4. So basically this is the picture of what we're doing. This is the parabola y equals x squared. And what we're doing is trying to find the length of the arc in between those two values. I'm going to guess it's going to be some horrible value. You can use your calculator to actually find the decimal expansion. We'll get the exact value computing this. So L is equal to the integral from a to b of the square root of 1 plus dy dx squared dx. If you're going into an exam or you're preparing for that, you should probably have that memorized by now, or you want to become awfully familiar with it. I can't guarantee they're giving it. So what we have to do with this is every time we have to find the bounds. If they're nice, they gave it to us. X is 0 and x is 1/2, so we already have the bounds. What we do need to do every time is compute the derivative dy dx, or dx dy sometimes, case depending. But in this case, we're going to have to take the derivative, square it, add 1, take the square root, then simplify and see what happens. And then we'll have to compute the antiderivative. So in our case specifically, L is equal to the integral from 0 to 1/2 of, what do we need? I don't like to do that ahead of time. What I like to do first is build what we need and then put it into the machinery. We're going to chop the problem up into its pieces first. So dy dx, we don't even need this squared. First of all, what we're going to compute is dy dx. So y was x squared, so the dy dx is 2x. Once I do that, I need that squared. Dy dx squared is 2x squared, which is 4x squared. Then I need 1. Dy dx squared plus 1 is equal to 1 plus 4x squared. And so we can't simplify that in this case. We're going to have to use some other clever technique. Now that I have that, the length of the arc is equal to, I don't need this, the integral from 0 to 1/2 of the square root of 1 plus 2x squared dx. There's more than one way to do this, but basically if I make a baby substitution or a linear substitution, I can turn this into u first, and then we're going to have to probably, I see that it's going to be a trigonometric substitution. You can do this all in one go if you want, if you're more sophisticated, but at first I'll do the baby substitution and then I'll do the trigonometric substitution, and we'll change the limits and get practice with that as we go. You can do it all in one by setting this equal to tan theta, but we'll do them one at a time. So this is x equals 0 to x equals 1/2. So I'm going to let u, which we shouldn't do, so we're going to use w. W is going to be 2x. Then dw is going to be 2dx. All I have is dx, so we'll divide by 2, and I get dw over 2 is dx. And then now that I actually have limits, because we're actually computing something, I have to change the bounds. So when x is 0, this says w is 2 times 0, which is also 0. And when x is 1/2, this says w equals 2 times 1/2, which is 1. That wasn't so bad when it changed the bounds. Sometimes those can get nasty. So equals, we're liquidating x. All x's must go. When I change those, now where was w going? W was going from 0 to 1. Then now I have the square root of 1 plus w squared, and then I have 1/2 dw. Now that I've made that substitution, I see that we're actually going to now make a trigonometric substitution. You could have done that all in one, but now I can see it much easier. So this is equal to 1/2 the integral from 0 to 1 of the square root of 1 plus w squared dw. I want to let w equal tan theta. then dw equals secant squared theta d theta, and the square root of 1w squared is the square root of 1 plus tan squared theta, which is the square root of secant squared theta, and on the domain that we're using this is positive, so technically there's absolute value, but we're getting rid of it. And so secant theta. Once I have that, I now make this trigonometric substitution. This now becomes 1/2. Oh, also I forgot to change the bounds. So when w equals 0, this says 0 equals tan theta, which says theta equals 0. And when w equals 1, this says 1 equals tan theta, which says tan theta is what? From the disembodied voice behind the camera. It's too late now. It's too late now. You blew it. Test 1F. Making the substitution from w now to theta using trigonometric substitution, we get the classic integral, the integral from 0 to the well-known integral, for those who well know it, the secant cubed theta d theta. I'll do this one in a different video. This is integration by parts. This is the clever trick. Actually, you leave it like this. This becomes dv, and this becomes u. And this is also why we don't use u for regular substitution, because if I have to use integration by parts, but I'm not showing you. This is 1/2 times that, already 1/2. Then I get another 1/2 from, this is the natural log, or sorry, jumping the gun, secant theta tan theta plus the natural log of the absolute value of secant theta plus tan theta. That should be absolute value. Evaluated from 0 to pi over 4 by the fundamental theorem of calculus and integration by parts using that substitution. So now that we have this equals 1/4, now what? Because we don't need the clever triangle this time to turn those back into x's and go all the way back. That's for a story for another video. But because we have bounds now, we just put everything in there. So this is the moral of trigonometry also. What's secant of pi over 4? I don't memorize that. I remember cos of that and upside down it. So cos of pi over 4 is 1 over root 2. So secant of pi over 4 is root 2. So this is root 2. Tan of pi over 4, this is how we calculate. We get the power series. Tan of 1 is pi, or tan of pi over 4 is 1. So arctan of 1 is pi over 4. This is how we calculate pi. So tan of pi over 4 is 1 plus the natural log of the absolute value of secant, again, is root 2 plus 1, which is a positive number, so we can get rid of the absolute values. And then now minus 1/4 times, we put 0 in here. So cos of this is going to be 1, and then this will be 0, and then plus natural log of 1, and then 0, so this will be natural log of 1, which will also be 0, so this one will just go away. So the final answer is 1/4 root 2 plus the natural log of root 2 plus 1. I told you approximately equals some number. And just got black on the carpet. Put the cap back before your mic drop.